seconds.
Hi, my name is Faisal Masood. I'm a principal architect at Red Hat Asia Pacific.
Hi, I'm Tom Corcoran, a principal AI specialist at Red Hat. Welcome to the next video in the series featuring the Red Hat Data Science platform. In the previous video, we featured natural language processing, or NLP. Today, we'll be doing image classification and, in particular, detection of events within the video. Check out the description for the code base for these and other use cases. And of course, the same Red Hat data science platform can be used for many, many AI use cases.
Thank you, Tom. And just to re-emphasize, in this video series, we are tackling two major challenges. Number one is to provide a consistent environment for the data scientists. And the second one is ease of use by which data scientists can take their model and deploy in a consumable fashion. But in today's video, we'll not only show you the data science lifecycle for the use case that Tom has mentioned, but also show you how to capture the video from edge locations, store it, process it, and then infer it at runtime to generate business events. And again, as usual, to start our data science part, Saeed, our data scientist, will start the discussion.
Hi everyone, I'm Saeed, Senior Data Scientist and Machine Learning Engineer at Red Hat. Today, as Tom and Faisal mentioned, today's problem is related to the image processing. Previously, we tackled the problem related to the fraud detection, and then the other things were natural language processing. But today, we want to detect the events that's related to the image classification or image segmentation that's happening in the factory, in the production lines, we want to do it via OpenShift.
So today's use case of image classification and detection of events within the video could also be applied to other use cases, like, for example, on the factory floor detecting faulty equipment, or in the radio tower detecting images that look different to how they should look.
Yeah, in a factory, to manage the crisis, we need to process the information that comes from various cameras that exist, and then today we want to showcase them. What kind of application we select. We make the application more simple. We just train a model, gather the information based on whether there is a person in the camera, in our laptop camera, or there isn't any person, and then based on that try to define a data set. We read the data set from our storage, and then do some pre-processing on that, rotating, flipping, this kind of things. And then after that, train the model, define the models based on the efficient we want, and then to train the models via the TensorFlow, then validate the solution, and then put the model in, after the validation, put the model in the production. This was the steps that we did, and then we provide the model. And then the next step is to use this model with the other tools.
Okay, so just to recap then, with the Red Hat Data Science platform, we can bring a consistent development environment for models and also bring a much faster time to value for your AI/ML projects.
All right, so now the model has been built and developed. As Saeed mentioned, the model we developed today is to find out if there is a person in the video feed or not. And so now the second stage is when we want to apply or infer that model in production, we have to consume the data from edge location or from your laptops, from different video cameras, and store it, process it, and then send it to the model. So what we have done today is we actually wrote some code that help you capture the video first. So you can see here in this code, we are capturing the video from the video device. Now this code can run on the edge devices, on your laptops, or wherever the video camera exists. And then after that is capturing frame by frame from the video, and then is forwarding each frame to a Kafka topic. And that Kafka topic is available in the central location or at the edge location. And from there, what happens is we receive the video from the Kafka topic, which is each and every frame. We decode the frame, and then we'll pass out the frame to our model to find out if there's a person in this frame or not. So you can see the same Red Hat platform not only used for the data science lifecycle, building, deploying, and running models, but also ingesting, storing, and inferring data at scale with all kind of data like videos, audios. In the previous time, we have talked about text and normal floating number data. So this is the demo for today, and of course, as Tom mentioned before, the code is available in the GitHub, and the description is in the line below. Thank you.
Thank you.
Thank you.
So, that's good.